With the advancement of semiconductors, an evolution of semiconductor process is now due to increase the yield and lower the defect rate. The smaller the semiconductor, the shorter the circuit width, that is the distance traveled by electrons, improving the performance and reducing the power consumption. This is why a finer detailed process is required, calling for more time and money to be invested into the semiconductor process. In this context, if the DBG process is introduced in the wafer back grinding process, which makes the back of the wafer thinner, the semiconductor manufacturing process will advance a step forward. However, there are several problems in introducing the DBG process. Most wafer back grinding processes currently use the tape-type approach, but if you perform the DBG process in this tape-type approach, the chipping and dust phenomenon will occur in the fine gap of half sawing. Also, the film will only stick to the micro ball on top of the pattern, causing the fixation power to decrease. This lowers the flatness of the chip during the grinding process, resulting in defective products. It takes 3 times the material as the area to cover all the wafers, and more than 60% of the film is discarded, wasting both money and resources. The new Wafer PRM coating agent developed from micro-sol will now transform the paradigm of wafer back grinding process. Once the PRM coating agent is dispensed onto the wafer, it is compressed in vacuum and then thermally dried. A thin film is formed on the wafer. Because the micro-sol penetrates into all empty spaces of the wafer, there are no gaps, preventing the source of chipping and dust phenomenon from the beginning. Fixation power is also improved because the coating agent adheres not only to the ball, but also on the pattern. This is a key factor that maintains flatness. The existing film tape approach was prone to the embossing phenomenon when the vacuum pressure was applied to the thin surface of the wafer. But when you use the wafer PRM coating agent, it is not affected by the vacuum pressure because it covers all the gaps. A maximum pressure of 80 to 85 megapascals can be applied, increasing speed and task efficiency. Through this, the efficiency of semiconductor manufacturing process also increases. The existing film approach requires 6 stages of processing, but the PRM coating agent only requires 4 stages, cutting the cost of equipment installation and increasing production yield. Also, because the film can be applied onto the circular shape, unlike the rectangular film, there is 0% of material loss. Whereas the cost of film material was up to $3.50 to $5 per wafer, the cost is reduced to just $1, resulting in a saving of over 60%. By thinking outside the box and pursuing new challenges, the Wafer BMP coating agent is challenging the paradigm of semiconductor manufacture. BECS is leading the innovation of semiconductor manufacture. BECS is leading the innovation of semiconductor manufacture.